Hello, everybody. Welcome to our talk. So this is something that's been quite a long time coming now, something we've been working on at Block for, 6 or 7 months so far. My name is Brian Gardner. I work at Cash App.
I'm Sam Edwards. I work at Square, and together we work at Block.
Yeah. If you didn't know what Block is, it's Square with one extra dimension. We're going to kind of cover some of the work we've been doing on AI-driven mobile testing. Overall agenda here, broken up into kind of 3 main areas. First off is kind of an introduction into the current project, and then going into kind of how this project started. Then kind of digging into going from an initial prototype to something that we actually use in our production test suites on both Cache and Square. And then some future plans that we have going forward. So this project started sort of out of an idea from droidcon of last year. I'll talk about that in a little bit. But over all of this time, we have actually gotten it open sourced. So if you go to Block's GitHub page under Trailblaze, the library is currently open source. A lot of the tests you'll be seeing are available in there. You can pull it down and start playing with it. There's no GitHub or like Gradle artifacts quite yet. We're still pretty heavily iterating on it, but it's pretty easy to pull it down and get it working with your own applications. And for right now, let's take a look at what it can do.
Thank you, Brian. And a challenge, I saw about 60 people in the audience. I think we have 41 stars on GitHub. If we can have 100 at the end, that would be awesome. All right, so I'm going to demo what we have today in open source. So if you pull this down right now, you'll have exactly what's in this open source directory here. But here's some examples. I'm going to be showing this clock test today. So down up here, you look and you see a normal test that runs on a Android phone, right? So you have your class, you have a rule set up. Now the special thing here is we have a Trailblaze rule, an Android one. And so you can specify the LLM client you want to use. We've been using OpenAI primarily, but we're leveraging Coog's framework. It's from JetBrains. And so you can plug in the Gemini 1 or whatever else you'd like. And then additionally, you specify your model. We have 4 to 1 here. So for a setup, we're just going to launch the desk clock app, which is the alarm app. And then we're going to set an alarm using natural language. So this is the way most of our tests kind of look today. It's natural language inside of a normal Android test. Now the thing is, you can write any code you want before, any code you want after. You don't have to do anything that's special with Trailblaze. Trailblaze is just a thing that you can use in here. And this is how we're doing it right now. So let's go ahead and run this test. We're going to run set an alarm, not set a debug point. But this will run just like any other test does. What's happening is it's actually behind the scenes, it's taking the OpenAI key I have on my laptop and it's pushing it over into instrumentation argument because all this stuff's actually happening on the phone itself, like all of the agent loop, all of the API calls, and hopefully it'll run here. Okay, small, it's connected, it's running. Let's see here. Pull this over. We have a log server that hopefully will get something, there we go. It's starting. All right, so this is our log server. You'll hear more about this later, but like as it's running, this is going to give us an insight of like what is going on with the LLM. So as we saw like in the test, we've given it this objective or a prompt, and it's trying to do it, but it's a live demo, of course, so who knows? Refresh this, make sure I have internet, and I do. So theoretically, it should just be interacting with the UI there, and it's not doing anything right now. So we expected something like this to happen. We can try to run it again, and we'll give it a shot. I think everything's set up right. I'm going to restart the local server just to be sure. So I've got connectivity right now, it looks like. So if I pull, I've got connectivity, so it's not that. Let's see here. Running another one, we should have a second session come up. I think that's the one we already had. Let's see. All right, this is going to be a pretty lame demo, but we have more demos later on that hopefully the demo gods will be good. But this gives you a general idea, I guess, of it's going to be running on the device. You describe it in natural language, and then the AI stuff would go ahead and do it. We can actually look at Logcat because that's going to tell us a little bit more. It might be that it's timing out with OpenAI right now, which has happened before, and of course I just Logcat. So you can see it's trying to do it here, but it is not. So all right, let's continue on, and then we'll go from there. Live demos, woohoo. And continuing. Yep.
All right, in the interest of time, we'll do some more demos later, like we said. But first, let's kind of take a look at where the initial prototype for this came from. So last year, droidcon 2024, at a lovely Greek wedding venue somewhere else in Brooklyn, there was a session by some like senior developers on how they are currently using AI in their like developer workflow and things. And I remember Ty Smith made a comment on like, hey, we're using AI in some of our end-to-end testing. We're testing like our rider and driver apps in production. We're seeing some pretty good success with that. So I figured, well, this sounds pretty cool. So on the way home, I did some more research. So Uber posted a article in April 2024 talking about the original sort of setup for the agent. And looking at sort of all of the things they were specifying, it didn't look that complicated. So they were passing in some sort of test goal to the agent, like, oh, request a trip on UberX. They were processing the UI and passing in all of the important like UI buttons and text into the LLM, and they were passing in a list of previous actions. And then based on all of this data, the LLM would spit out some sort of action that's like, oh, tap on use UberX or whatever. And it just kind of kept going in a loop. Now, Uber was doing a lot more like hard machine learning stuff because like LLMs weren't quite as good as they are now. They were doing some custom like computer vision models to like parse the UI and pull out the important things. But when this project kind of started, like GPT-4o came out. It was like doing reasonably well with tool calling. So we kind of wanted to give that a shot first. Moving later and calling out Stacy's thing, we are shifting left apparently. So like they're continuing to invest in this. We felt really good about kind of continuing to invest in this as well. Shout out to Anam over there. We collaborated really heavily with him and a lot of other folks working in similar places on AI end-to-end testing. There's a lot of great stuff in here, and I think it's a really tractable problem that we can solve. So coming back into Cache, when I first started, I was kind of taking stock of where our current end-to-end test setup was. Like what tools were we using? And chances are it looked very similar to a lot of other folks. So we had a large suite of automated tests that were using tools like Espresso, UI Automator, and Compose Test Rule to like find all the stuff in the UI and drive the interactions. But we also had a very large set of manual tests. I think at Cache, like we spend like 3 days per release running manual testing. That's a lot of time, that's a lot of energy spent on that. And if we can update all of these things to run natural language tests, that's gonna save a lot of time. It's gonna speed up our learning, our feedback cycles are gonna get faster so we can just ship more. Now, when I started on this, I wanted to have like a really close, like a well-defined idea of what this project was for. So I want to say like, hey, what does AI-driven mean? If you look up research papers, there's a whole lot of stuff going on in AI testing right now. You can find papers on people generating new unit test cases with AI, generating test fixture data with AI, and all kinds of stuff, but that's not what I was really going for. All I wanted was, given a natural language prompt, my AI can verify the expected app behavior. So I can tell it, hey, go log in with this email address, this password. It'll figure out what's on the screen and drive its way through, and then it'll tell me when it's done. So with the goal in mind, we started relatively small. So I randomly found an OpenAI wrapper library in Kotlin. Seemed okay, so I decided to use that. No reason in particular other than I had heard of OpenAI before, and that was about it. I had zero AI experience here, knew nothing, so it was kind of like jumping in the deep end. So how this basically works is every request we make to the LLM is called a chat request. So we tell it what model we want to use, we give it some information about like the current state of the world, and we give it some tools to call. Now even the tools were a little suspect back then because people were still split on like doing structured output parsing versus these newer tool calls. I didn't really feel like going through and parsing out all the JSON and all the hairy stuff with that, so I said, hey, we'll give tool calls in a test run and see how it goes, and they work pretty well. When the model responds back, it basically has 2 bits of information we care about. Number 1 is the message. This is where the LLM sort of like gives you its thoughts on like, here's where we currently are, here's what's on the screen. Based on these instructions, I should do this thing next. and then it will call some sort of tool for us to use. And like I said, that's basically it. So all of this effectively happens in a loop. So for every task we have in our instructions, going back to the login example, we will continue making requests to the LLM, parsing the responses, and doing whatever actions it says until that particular task is done. So specifically for our LLM requests, if you want to dig into Trailblaze, you can see where all of this chat message stuff is set up. Originally, I used the GPT-4o mini model, mostly because it was cheap. I think I put $50 into my personal OpenAI account, and I was like, okay, I'm going to use this. After a month, I think I spent $1, so it wasn't too bad. The tools are a little bit more. We've had to do a lot of tweaking with the tools. Initially, to start out, I basically said, hey, what are a few basic actions a user would take? You can tap on stuff, you can enter some text, delete text, scroll on the screen. That worked pretty well. Another tool we added pretty quickly is a halt function. So I did not want to have to do my own checking to see if the AI was where it was supposed to be. I wanted to give the AI instructions and be like, hey, you tell me when you think you're finished. So once it's gone through the login flow, it'll say, okay, I'm all done. Let me know what the next task is. The chat messages, this is where is the AI's view of the world and what you want it to do. Ours are broken up into kind of 4 distinct areas. The first of which is a system prompt. This is basically just what the AI's job is. This is a snippet from our existing system prompt. It's you're an assistant managing a user's phone. You're going to autonomously complete tasks and report back when you're all done. You'll be provided with instructions, blah, 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 blah. There's a lot of stuff in there. The instructions themselves, these are the actual test objectives. So you're going to go in and log in, or you're going to go order a card and make a purchase, things like that. The history is something that is really important for these kinds of models. One of the early things you'll learn about these kind of chat requests is that the LLM has no concept of memory between chat requests. So each chat request must stand on its own, even if you're continuing to do stuff. So we provide the history of all of the actions that the agent provided. So tap on this, enter some text, and we also provide the results. So were we successful doing what the LLM wanted? Adding this history is really important so the LLM can figure out okay, I've already done all of these things, I still need to do these other things, and it can kind of orient itself for what it still needs to do. Last but not least is the screen state. So this is where we're just hey, here's what's currently on the screen. Originally passing the full view hierarchy to the LLM, as well as a screenshot. Now in the initial implementation, I was chaining all of the screen states in all of the chat requests. That was bad. All of the screenshots led us to quickly blow through our context window and got really expensive. And even if removing the old screenshots, it would still get confused by having the old view hierarchies there. It would try to refer to views that were on previous screens, but try to perform actions on those. So that didn't really work. So now we just provide whatever is most current. So we're just hey, you've done all these actions, but here's where you currently are. And that usually gives it enough context to figure out what it needs to do next. After a few weeks and probably 400 to 500 lines of code, had an initial prototype. I think about 200 lines of that was the original system prompt that I put out. So really not a lot of code to hook all of this up. And it worked okay. There were definitely issues that we ran into, but just the speed at which we were able to build this thing and the general performance we got out of it made it pretty clear that it's something we wanted to invest further on. And invest we did. So we have a ton of other people on the project now. Sam joined super early doing that. Rodion here in the front also joined. He's helping out with a lot of our testing things. We continued reaching out to Anam and some other folks in the community because we really felt that this was something that everybody could benefit from. So once we got to around March, we had kind of a foundational API we thought would be good to open source. So we got the name approved in March, and then 2 weeks ago today, actually, it got pushed out to open source. So very excited to see what everybody can build out with it, and we're going to keep investing heavily in it.
All right, so it was great. We hopped on this project and we had something working, but was it working fully? We're just going to run this again as well, just to see if it works in the background. If we see the device moving, we know it works. All right, I'm going to go from here just to see if we see the device moving. All right, so productionizing. As we go forward, we wanted to figure out how are we going to scale these tests, right? So if I'm writing one of these tests, you saw it on my development machine here. It is an Android test. One of the reasons why we chose to do it on device was so that we could leverage all of our existing infrastructure. So we already have this test farm like Firebase Test Lab that lets us go out and run hundreds, thousands of tests in parallel. And so by doing it on device using, we started with Espresso, we figured we could leverage that. But then we have the problem of how do we debug these tests? When something goes wrong, even like what we're seeing here now, it's still not working, so hopefully we'll get a good demo later. You got to figure out how am I actually going to debug and figure out what happened. And you got a little quick glimpse there into our log server and like what's happening, and so that's really helpful, along with like ADB logs and stuff. And then finally, like once we actually run through a flow with AI, how do we record that so we can play it again, right? Like who wants to call AI every single time? The answer might be in some scenarios you need to, but in a lot of cases, once you run through it once, there might only be one section that needs AI, or or maybe none of it. So the scaling part, like I said, we wanted to reuse our existing test farm. If you look at a lot of solutions now, if we had built all of our AI stuff on our laptops or host machine, we'd have to then spin up a device that connects to that and so forth, and there's a lot of just infrastructure stuff that we would have needed. And so we figured this solution allowed us to go forward, and I'm hoping that all of you out there can try this because you can run all this on your Android device. All you need is that Open API key or Gemini key or so forth. This allowed us to scale. It also meant that we had the support of our mobile developer experience team, the people that manage our CI/CD and our test farm itself. So this is something that, again, don't solve all the problems, so they can handle that, and then we can just work on the AI testing part. The AI interaction. So once you have the AI come back and tell you what to do, now you have this tool call. You have like a meta thing that says, tap on this or input this, but it actually has to happen on the device. So originally we started with just Espresso, and that was great, but then we had a view that had Compose in it. And Compose can't be interacted with at Espresso because it's a view, you need a Compose test rule. So that got kind of complicated. There was no good way to get a full picture of what's going on. So then we swapped over to ADB, and ADB is amazing. If you guys could listen at the same time, Matt McKenna is doing a great talk, you should watch the recording later, about doing an MCP server that controls the device over ADB. It's a really powerful way to control a connected Android device, but again, you need to have the host machine to do it, and it only works on Android. We looked at UI Automator, which allows you to run a lot of the ADB stuff on device, but the UI Automator APIs, I think we're all aware, aren't the best. They're working on, I think, a new version of it, but that wasn't great. So then there's something that's been out there for a long time, which is Maestro. So Maestro has a really nice, really nice command surface that's already available. It's super readable. I don't have an example of the YAML here, but these are all the different commands it already supports. You could do things like paste text or click on something or any of these things. All this stuff already exists, and they did a really good job of approaching it in natural language. And additionally, Maestro has drivers for iOS, Android, and web. So then we said, wait, Maestro's written in Kotlin. Kotlin can run on device, it can run on host. So then I looked in deeper and tried to figure out what we could do. Now again, they're host mode that running on your laptop or on a machine that's controlling the device. They have Android, iOS, and beta web support. But our on-device, how are we going to approach this? So what do? You roll up your sleeves, if it's not 100 degrees and you have long sleeves, and you deep dive. So if you want to read this blog post, I published it in November, right after I joined, and we were trying to figure this out, but I dove into how Maestro is actually doing what they do, right? They're controlling it this abstract way of being able to control different implementations on different platforms, and it was really eye-opening, and it gave me the idea of being able to combine and create a completely on-device driver for Maestro. So by doing this now, we have our on-device Maestro implementation that can do everything and use the same API Kotlin services that Maestro has, but we can then run it purely on device, leveraging our test farm. So we talked about tools a little bit, Brian was saying, and tools are the key part of having the LLM instruct us on how we can interact with the device. So the first thing we did was these JSON objects that are coming back. It's just that raw JSON, and then we're getting the value text off of it and doing an Espresso matcher and clicking, but we talked about the problems we had with Espresso, and ADB doesn't work on device purely. So then we said, what about type-safe tools? What if I could say, this is my type-safe data class, I just need these parameters left, and then I could just register that with the LLM and have it call that, and it's super easy to have clean code, and that was really cool. And this worked really well, but this is the point in time when Maestro came in a little bit more, and we're like, wait a second, what if we just give the LLM Maestro? that would be amazing. So this is like, this is their internal API surface. Once you write YAML and it parses in their Kotlin code. But this is a tap on element command, and it has a selector where you could do view by ID or by text and all these other parameters. And you looking at this now, you can't read all this in one, I can't read all this in one glance. And the LLM is the same way. It's not able to understand how to provide parameters for all of these. So you need to really like give something more simple that the LLM can interact with as far as the tool is concerned. Additionally, like if we implement it directly with this, we're 100% tied to Maestro, and Maestro is a great way of representing these commands and is there, but we wanted to like not have a direct, completely reliance on that. So our final solution was back to solution 2, where we had our type safe, nice way that the LLM can interact with, but we have some commands that map to Maestro commands. So if we want to interact with the UI and it's a supported thing by Maestro, then we can just map over to their tap on element with text and a long press. And so that gives us the ability to have our own way of interacting with the LLM, having the best tools that they're able to call, but then able to use the Maestro command API surface so that we can use that to drive to the device. So finally, we have these like platform agnostic type safe tools called Trailblaze tools. There's 2 types of Trailblaze tools. One is an executable one. That's one that can like interact with the device or do something immediately. And secondarily, there's one that the LLM can call, we call it a delegating tool right now. But basically it comes back and it says, oh, I'm actually not a tool myself, I'm a meta tool, so I can go call these other ones. So I can call 3 or 4 in a row. And when these tools are executed, we have to give it the context. So basically, as it executes in that body, you give it like, here's the agent to perform any actions you want to do, here's a current screen state, and here's a request ID that we kind of pass through from the original LLM request to all the cool tool calls and driver calls to be able to debug how where that came from. So yeah, it didn't run, did it? Oh, it got failure. All right, failed to resolve OpenAI, so.
Is OpenAI down?
It's up. Maybe we'll get better later, but all right, cool.
All right, speaking of challenges, our challenges did not limit themselves to just on-stage demos. Now, working with LLMs is hard, let's say. You hear a lot about like AIs hallucinating and making things up, and this is something we really like wanted to combat against, because like the whole point of testing is we want to make sure that this thing actually does what it says it does. So some of the challenges we faced, first off was just debugging. So there's a lot that goes on behind the scenes for every request we make to the LLM. There's a lot of data we're sending with the screen state and the chat messages. And then there's a lot of data the LLM sends back, like what message is it sending, like how is it thinking about the problem, and where it's like how is it breaking down the steps. Also, like what tool calls is it making? Is it picking the correct tools for the situation? Is it struggling to find things like that. So we really like focused hard at the beginning on getting a solid logging framework down that you've seen. That will show like every request we make to the LLM. It'll show all of the tool calls that get made, all those tool calls, how they get mapped to our Maestro driver, so how those are triggered and so forth, just so you have a really clear view of what's going on. Another one of the early issues we ran into is sometimes it just wouldn't call any tools. Very frustrating. And then also occasionally it would just like interact with the wrong views. It was like trying to accomplish something, but it would get kind of stuck and pick the wrong thing. Now debugging, we talked about this before, but our goal for this was to have something that would run only on device. Like we don't want to have anything running on a laptop if we can help it. We only want to run on the device in our CI farm, so we have a really low memory footprint. CPUs aren't great, so we're really resource constrained there. So the approach we took is the log server is something that actually runs locally on your host machine while you're developing. And from the device, it sends HTTP requests over to forward the logs off the device. So like none of the processing has to happen on the actual emulator. We can kind of offload that. Now, in cases where you are running on CI and we don't have the log server hooked up, we do write to disk for all of these things. But after that, we compile all of those logs together and pull them off. So no matter where you run your Trailblaze tests, either locally or on your CI system, you will have access to the exact same logs. They look the same, have all the same information, so it's really good for debugging, especially when stuff blows up in our CI system. Yeah, because our eventual goal is to like be platform agnostic here. So again, doesn't matter where you run your tests, we want you to have access to all of the same information. Now, we got a really good workout with our debugging tools because sometimes the LLM is, I don't want to call it lazy, but that fits. So occasionally you'll make a request to the LLM and you'll say, hey, here's the screen state, here's what you're trying to do. And it'll give you a really nice message back. It says, oh, based on where we currently are, I think I need to do this next. And in the message, it'll say, I'm going to call this tool. And then it won't. It just doesn't return a tool call. It's very frustrating. Now you can kind of like get around this sometimes by like prompting it differently. You can like use all caps and say like, you must return a tool call. That'll work sometimes, but not always. This also heavily depends on which models you use. So the 4.0 mini model did struggle sometimes with tool calls. We have a lot better success with like GPT 4.0 or 4.1, but we still do have cases where that doesn't work. And what we do here is we still add this message into our history stack because it has all the information about like, here's what the LLM was thinking, here's what it thinks it should do, it just didn't do it. So we send that up in the request, but you can force it to call a tool. So normally we use the auto mode so it can decide if it wants to call a tool or not. But we can force it by putting required, and then it'll submit the correct tool call. Now, if you're wondering, well, why don't we just do required all the time? The reason for that is most models, when you require them to return a tool, they will not return any message data. And that's a problem because that message is basically the LLM's chain of thought. So it uses those messages to determine like how far it's gotten in the process and figure out what it should do next. And if you get rid of all of that data, then your performance is going to go down. So we only do this when absolutely necessary. And in the next one, the LLM would sometimes pick the wrong views to interact with. This is something we didn't really run into until we were doing like a checkout test on Square. You would go in and like search for a bagel, and then you wanted to tap on the bagel. But at that point, there's 2 bagels on the screen, or 2 texts that say bagel. And it was really hard for the LLM to figure out which one it was going to use. Now, one way we can get around this is by specifying our touch events by XY coordinates. So this works really well. We have all the bounding box information through the view hierarchy, and it works great. Except it's not really great for recordings, because as soon as you try to run this test on like a different size device or something like that, those XY coordinates are not valid anymore and the test isn't going to function properly. So XY coordinates are great if you're just like messing around and want to test out how something is working, but it's not great for like longer term usage. So next we moved on to like, okay, we'll tap on the text or tap on something with the ID. But even this can be a little ambiguous, especially the text portion. So we needed something a little bit different. So like repeated text on the screen, that's not great. If you have icons on there with no accessibility text, that's bad. Not accessible apps are not good. But this is a really easy way to find them because the model would be like, hey, I want to tap on this thing, but there's no identifier for it to tap on, so it'll just fail to do so. So we needed something else to handle this. And again, shout out to Anam and the rest of the community for some good ideas. They introduced us to something called set of mark prompting. Now, what this does is it's a little bit of pre-processing you do to your images before you send them to the LLM. So in this case, the picture on the left is the default one. The picture on the right is the marked up one. So for every like element in that picture, I don't know if you can see it, but each one has been annotated with a little number. And when you send this to the LLM, what you do is you say, okay, when you want to click on something or interact with something, use the node ID for it instead of like the text or anything like that. So all of the node IDs are separate. We can sort of handle those ourselves. And it gets rid of like any ambiguity that there might be. Now, when we first saw this seems really scary, sort of. I think some of the first images we saw was like a bowl of fruit, and then it would like color in the apples in the bowl, and we're like, this seems really hard. This is like hardcore computer vision sort of stuff, like image segmentation and whatnot. Fortunately, we didn't have to do any of that because we do have access to the view hierarchy. So we already have access to all of the bounding boxes for all of the views and everything. So all we do is we filter out the views that we really care about, normally anything with text or images or click listeners. and then we just draw bounding boxes around those and give it the little number. Now, what the tool calls look like for this is, so on the left, we say, hey, like enter the last name. The tool call says, hey, all right, tap on a node by ID. So it's giving the node ID of 34, which you probably can't see, but the last name field on the left is 34. Tapping on it by node is a delegating tool. So under the hood, we will take that node ID and process a good selector for that particular view. In this case, we just can use the text of last name because it's unique on this screen, and then just tap on it.
Cool, so we've gotten a lot of insights on the problems that we faced and how we got around them, but I wanted to give a quick high-level architecture. And this is probably something that we could sit down and have coffee and do this for a long time, so let's see if we can get it. So high level, the inputs to Trailblaze are prompts, natural language. You can additionally have Kotlin code, as I talked about, and you can have recordings, which we're still working on. We have some internal ways of doing it, but we don't have a fully fleshed out way external yet, but it's definitely on our roadmap. So you have your test definition. Those prompts and your Kotlin code, if it's a natural language piece, it goes to the agent and our LLM loop that we've been talking about, and that produces tool calls. Those tool calls, like we said, are type-safe Trailblaze tools, we've called them, and so it ends up resulting in Trailblaze tools. So this section here is like our primitive thing that is interacted with. So you can interact with it with your code, or the LLM can call it. Now, based on that Trailblaze tool, we could then do the map to Maestro thing, where that Trailblaze tool says, hey, I can go ahead and fulfill the action that I'm interested in by using some Maestro command that exists, or I could call my app-specific code. Maybe I want to draw a signature for Square, or I want to do something special that's not built into Maestro easily. A lot of the things just came on here, but the big thing is that on the right, you have the executing device, and on the bottom, you have logging. There's a lot of things going on. What I want to show is that this is the only piece that is platform-specific. So going back, this is all of Trailblaze, and so everything on the left, and I maybe should have inverted it the way it is here, but everything on the left can be reused across all platforms. Only the executing device here, which is going to be the on-device Android one, or one of Maestro's implementations of Android, iOS, or web, is there. So we can reuse everything that's done in Trailblaze, and it's not tied down to this. We have a lot of flexibility, and that allows us to port our logging to use on iOS and different platforms, and hopefully the demo gods will help us with that. Let's see.
All right, real quick. So we got a prototype ready, moved on to productionizing it. Now we can talk a little bit about future planning. And we really want to focus on adoption and investment. So we're really pushing hard for this adoption internally at both Square and Cache, because AI testing is probably going to be a pretty major paradigm shift in AI, or like in mobile end-to-end testing. If you've done any Android testing before, you know it's not great. It hasn't been great, so hopefully we can make it better. A huge reduction in manual testing effort here, as well as more resilience against UI testing changes. If you can define your test in really high-level concepts, then if your button text changes or the placement changes, your test shouldn't have to fail because of that. Also, with adoption, the novel test cases that we implement are the biggest thing that helps us figure out what Trailblaze is still missing. So like the bagel example where there were 2 cases of the text on the screen, we didn't know that was a problem until we ran into it. So the more tests that we write, the more things we find that can be made better, and the more just improvements that we can make to the tool. Another thing we're focusing on is the difference between test authoring and test execution. So once you have your test, you can then just go run it wherever you want. You can run it locally, you can run it on your CI system, that's great, but we really want to try to get the test authoring piece down to make it really easy for people to write their own tests. Now, with your test writing, there's going to be a lot of stuff that's really hard to do with an AI tooling like this. So any sort of like account setup, or like authentication if you want to skip your authentication flow, or feature flags. Like these are things that pretty much every app is going to have to set up before their tests. So this is something we're really honing in on to try to make better for as we're testing here. One of the things that we're looking into for this is the concept of custom tooling. So you can provide your own custom Trailblaze tools specifically for your app in order to like do any setup that you might want. Some ways that we've used this, like at Square, is you have to like sign a receipt That's really hard to do with something like Espresso or UI Automator, so we can instead make a custom tool that will handle doing all of it. Or something like connecting a virtual card reader. Like these are very like our company specific things. These are probably not tools that other people would want, so we can define the tools that we need to help us the most. We're also going to be heavily investing in this going forward. We've got more people. We've got some people working on our iOS integration, which will hopefully be there. We have open sourced this, so again, if y'all want to take a look at it, give us feedback, help us build it, that would be wonderful. We are also working on MCP authoring improvements. So if you missed Matt's talk, basically it allows you to write in natural language what you want it to do, and then the MCP server will help Trailblaze do it. And last but not least, we want to extend beyond Android. So Maestro supports iOS and web. We're trying to get there as well. As Sam said, like there's not a whole lot that's different in the implementation. Like fetching the screen state, interacting with the device, those might be a little bit different, but the core of the library should be pretty much the same. And the goal, hopefully, is I have one set of prompts that are my tests, and I can just run both of them on iOS and Android, so I don't have to maintain double test suites.
It wouldn't be a block presentation without mentioning Goose. Goose is our agent that can run on your desktop, and we're going to show a demo of it now. And hopefully the demo gods, we'll see what happens. Who knows? All right, so we've got our local server running up. Just double checking to make it run again. Okay, here we go. Let's view our logs, and we are going to delete all of them and start Trailblaze in Goose. So Goose has a really cool feature called Goose Recipes, and that allows you to launch it with context. So over here, it's launched in a Trailblaze context. So it already knows that it should be using Trailblaze, the MCP extension here, and basically anything I interact with Goose here should translate over. So now it's saying, hey, I'm going to go ahead and help you figure out this prompt, which says using Square and set of marked tool sets, log in with Bart at SquareUp, which is one of our fake mode accounts, and then buy a bagel with cash and complete the checkout. So it's looking at the extensions, and the first thing it did is it connected device. It successfully connected to the emulator. So this part is using on-device control, and this MCP stuff will be open source in like the coming weeks, maybe a month, because I'm going to go on a vacation. But it went ahead and it called the device and said, what are the currently available tool sets? So here we've listed things, it's not beautifully formatted, but like default UI interactions, set of mark interactions, and then we have Square specific tools. So in this case, it's selecting the Square specific tools and the set of mark interactions, and now it's running the prompt over on the device. And this is the part where we'll see if it actually, I refresh that, so. It looks like our device just does not want to be happy today, so I'm going to launch another device just out of a YOLO sort of thing, and we'll figure it out. Actually, we'll jump to our iOS thing. So that was in this here. So we're going to turn host on device mode off, and we'll restart it. We'll start a simulator, and let's just fingers crossed that somehow the iOS one can connect, because it is connected to the internet as you saw in Goose. So iOS is booting up. I'm going to go ahead and start Goose again. Go back to home and start Goose. So here I have a session, and I'm going to do this prompt. So this prompt says, open the contacts app and add a new contact with the name John Doe and the phone number 123. So what we've done here is like we've said everything happens on the device normally, the whole agent loop. But now we're actually running the Maestro host mode, which again, this isn't open source yet, but this is the vision that we're going to get there. And so because of that and all the abstraction layers, it's able to interact with the UI using the same set of tools that we have, because Maestro's already implemented those for us. So it's a big like leg up. So hopefully this will work this time. Oh, it launched the app. Look, it's doing something. See, it's just iOS is better than Android, right? Yeah. Wrong thing to say here. So here goes. It's running. We can actually see row logs, but it started it. We have an objective that it's trying to do. If we look back over at Goose, it's waiting for it to finish. But what happened in Goose, which is really nice, is I told it to open the contacts app. But it, using AI, broke it down into multiple steps that are then sent over to Trailblaze. And so as it's going, we're seeing the logs. If I like don't touch it, I should automatically see the log server updating with like the latest state and so forth. So everything that's green is an LLM request. Let's like look at this one here. Let's see. So I sent this request off. What did we get back? I tapped on the add new item. Then I sent this off, and it says, hey, now I want to go ahead and tap in John Doe. And so it's going ahead and doing this for me. But I can see it as it goes. What's the thought process? If I wanted to debug it, I can look at what's happening inside of there. But yeah, we'll show you a demo later on for Android if you come over. But this gives you a little peek in there. So let's wrap up, Brian.
All right. Well, thank you all for coming to our presentation. It's been a whirlwind. Sorry about the demo issues. Like Sam said, if you want more Android demos, we'd be happy to show them to you. Please check out the open source stuff. Again, we are trying our best to build this in public to help out as many people as we can. Give it a try in your current test environment. We built it really to be able to be incrementally adopted. You don't have to throw out your entire test suite in order to use it. You can just slowly add AI tests if you want to. And if you all are working on any kind of AI tools at your own companies or on your own time, let us know. Maybe we can collaborate and work together and incorporate things, or maybe just build stuff on top of each other. But like I said, AI testing is probably the future, so let's have fun with it. Thank y'all.